Hello everyone. Let us solve a problem by using critical path method. Critical path method is used to find the critical path of a network. Let us consider the network. Take for example figure 1. So this figure 1 is the given network for which we have to find out the critical path. Like from 1 to 10, in which path should I travel so that my time will be the minimum. Okay, so it is called critical path. So as you can see, there are totally 10 nodes here. From 1 to 2 it takes 10 units of time, 1 to 3 it takes 8 units of time, from 1 to 9 it takes 4 units of time. Similarly, from 2 to 5, 3 to 7, etc. So, the circled ones are called nodes and the blue color things are the time units to reach from one node to another. So, when we are asked to find out the critical path for this particular network, the step 1 is to find the earliest start time and latest finish time for each node. Okay, that is the first step. So towards the first step, we are trying to redraw the circuit. If you see, this is my figure 2. Okay, this one is my figure 2. So my figure 2, I have redrawn the same circuit. Okay, so here when you take, I have replicated the same circuit. Now our job is to find out the earliest start time and latest finish time. So we denote the earliest start time by E and latest finish time by L. The suffix is according to the node. So E1, L1, E2, L2. Similarly, E3, L3, E4, L4. Similarly, E5, L5. Similarly, here it is E7, L7. Then here it is E6, L6. Next is E8, L8. Similarly, for the last node, it is E10, L10. For this node, it is E9, L9. So, I am finding out the earliest start time and latest finish time. So, let us start from the node 1. So, when you take this node 1, it is always the starting point. So, my starting time, earliest time would ideally be 0. Okay. So, from 1 to 2, I have only one path. It takes 10 units of time. We are proceeding in the forward direction. So, from 1 to 2, it takes 10 units of time. So, earliest start time is 10 here. Similarly, from 1 to 3, it takes 8 units of time. So, it is 8. From 1 to 4, it takes 9 units of time. So, it is 9. Okay. Similarly, from 2 to 5, it takes 8 units of time. But already to reach 2, we have taken 10. So 10 plus 8 is nothing but it is 18. Okay. Then you come to 1 to 4 to 6. So at 4 I have 9. When I add 7 with it, my A6 becomes 16. Okay. Now when I see for 7, I have 1, 3, 7, 1, 2, 5, 1, 4, 6. So, we should see all the three paths. When I proceed from 1, 2, 5, 7, this is 18 already. 18 plus 7, it becomes 25. Okay, keep it in mind. Next here, it is 9. Okay. Sorry, it is 8 here. Okay. So, 8 plus 16, it is 24. Here, 18 plus 7, it was 25. 8 plus 16, it is 24. When you come here, it is 16 plus 7, 23. Of all the three routes, I find the longest route here. So, while move towards the forward direction, I should consider the maximum time. So, according to this thumb rule, when 5 to 7 is expected, I get 18 plus 7, it becomes 25. Okay, so the answer is 25. Here I take the maximum path. Now, for 8, there is only one route. It is 18 plus 6, so it becomes 24. Similarly, from 6 to 9, only one route. It is 16 plus 5, so it is 21. Now, to reach 10, I have three ways. From 7, if you count, it is 25 plus 12, 37. From 8, if you count, 24 plus 13, again 37. Here, when you take from 9 to 10, it is 36, which is the maximum, either 7 to 10 or 8 to 10. Both give the value of 37. So, I have proceeded from 1, I have completed till 10. I move in the forward direction. When I move in the forward direction, I take the maximum distance to reach the particular node. So, it is mentioned by E suffix the respective node. We have calculated the earliest start time. Okay. Now, to calculate the latest finish time, we should go in the backward direction. Okay. So, when I go in the backward direction, I should consider the minimum value. This is my thumb rule. So, from 10, when I proceed, the actual rule is E10 is 37. So, your latest finish time must also be equal to 37. Always at the last node, both the earliest start time and latest finish time are the same. So, it becomes 37. So, when I proceed from 37, that is 10, when I move towards 8, 37 minus 13 becomes 24. Similarly, when I go for 9, 37 minus 15 gives you 22. So, backward I have to subtract. So, from 10 to 8 and 10 to 9, I have subtracted the time values. I have got 24 and 22 respectively. So, when I go to 5, it is nothing but I have 24 my latest time at 8. 24 minus the 6 will give you L5 as 18. Similarly, when I have 22 here, 22 minus 5 is 17 here, which is L6. Now, I go for 7. So, 7 when you take, it is nothing but 37, which is at 10, minus this 12. So, it becomes 25 here. Okay. So, mid values are filled. Now, from 7 to 3, it is 25 minus 16. So, what happens? It becomes 9 here. Okay. Then, sorry, I have filled in the fourth value. It is wrong. We have to go to the previous value. That is here. That is third node. So, 25 minus 6, it is 9 here. So, I have to write here. Now, this is 17 minus 7. So, it is 10 here. Okay. Now, from 5 to 2, 18 minus 8, it is 10 here again. So, we have filled all the values except for the node 1. For node 1, I have 3 parts from 2 to 1, 3 to 1 and 4 to 1. When you take from 2 to 1, it is 10 minus 10, which is 0. Next from 3, it is 9 minus 8, which is 1. From 4, if you take 10 minus 9, 1. So, we see we get 0 here, we get 1 here, we get 1 here. Okay. So, now we should take the minimum value when you move back. Minimum value is from 2 to 10, where it is 0 again. So, I am taking that value. So, the step 1, I have found out the earliest start time, latest finish time at all the nodes. Now, I go to step 2. Step 2 is where you find a tabular column of the values so as to calculate the critical path of your circuit. Okay. So, now I have listed the activity in the first column, normal time, earliest time, latest time, float time in the respective columns. So, normal time is called as D of ij, start time is, earliest start time is EI, finish time is LI. Finish time when you take earliest time, it is EI plus DIJ. Similarly, latest start time is Li minus Dij and the float time is given by Li minus Dij minus Ei. So, first I take the first node which is from 1 to 2. As you see, from 1 to 2, the normal time is 10 time units. So, I list out here. Similarly, from 1 to 3, it is 8. From 1 to 4, it is 9. Okay. So, from 2 to 5, it is 8. 4 to 6, it is 7. 3 to 7, it is 16. 5 to 7, it is 7. Then 6 to 7 it is again 7. 5 to 8 it is 6. 6 to 9 it is 5. 7 to 10 it is 12. 8 to 10 it is 13. 9 to 10 it is 15. It is the blue color values which are taken from the network. Okay. So now let us fill the earliest start time. So earliest start time, it is denoted by EI. As you see, we have E1, E2, E3, E4 up to E10. So we have to fill in the values accordingly. So when you take from 1 to 2, the earliest start time is 10. So I bring 10 here. When you take 1 to 3, the earliest start time is 8. So it is, earliest start time 1 to 2, this way, earliest start time is 1 to 2, 1 to 3, 1 to 4. For all the nodes, my E1 is 0. So it is 0 here. 1 to 2, 1 to 3, 1 to 4 is 0. Next is 2 to 5. When you take 2 to 5, the time unit is 10 time units. This node you have to take, it is 10. Next is from 4 to 6. 4 to 6 it is 9. So I put a 9 here. Then 3 to 7. 3 to 7 it is 8. So I put 8 here. When I go from 5 to 7, my time is 18. So I put here. 6 to 7 it is 16. So I put 16 here. Next is 5 to 8. It is again 18. Next is 6 to 9. It is again 16. Consider the starting node. 7 to 10 it is 25. Then it is 24. Then it is 21. Okay. Then we have to enter the latest finish time. That is L1, L2. So from 1 to 2 when you take, the latest finish time is 10. So I put a 10 here. Then from 1 to 3 when you take, it is 9. You have to go for the successive node. So it is 9. Then it is 10, 18, 17, 25, 25, 25, 24, 22, 37, 37, 37. Okay, we go for the successive digit. Okay, after completing this, I have to put EI plus DIJ. So, EI plus DIJ is to add these two columns. Okay, so I'll go for a different one. So, now it is 10, 8, 9. I am adding the first two columns. 16, 24, 25, 23, 24, 21, 37, 37, 36. Okay. Now, Li minus Dij. Li is here. Dij is here. I have to subtract and write. It becomes 10 minus 10, 0. 9 minus 8 is 1. 10 minus 9 is 1. 18 minus 8, 10. 17 minus 7, it is 10. 25 minus 16 is 9. 25 minus 7 is 18. Again one more 18. Then it is again 18. Then it is 17. Then it is 25, 24, 22. We subtract and write. Now for the final value float, it is Li minus Dij. That is, I am taking this value minus EI. That is latest start time minus earliest start time. So it is 0 minus 0. Let me use another color. So now it is 0. Next it is 1 minus 0. It is 1. Again 1 minus 0, 1. 10 minus 10, 0. 10 minus 9, it is 1. Okay. Then again 9 minus 8 is 1. 18 minus 8 is 0. 18 minus 16 is 2. 18 minus 18 is 0. 17 minus 16 is 1. 25 minus 25 is 0. 24 minus 24 is 0. 22 minus 22 is 0. So, we have calculated the earliest start time, latest finish time, normal time and float values. Now, I have to mainly note down the float values. So, when I see the float values, okay, we have to see which value to select. So, select the 0 values. 1, 2, 3, 4, 5, 6. These are my float values where I get 0. When you take the corresponding nodes, if you see, the values are 1, 2, 1, sorry, not 1, 4, sorry, 1, 2 has, then 2, 5, then 5, 7, 5, 8, 7, 10, 8, 10. These activities have 0 values. Totally we have 6 0 values. Totally we have 6 activities here. So my path is, it is like the paths are 1 to 2, right? 2 to 5, then 5 to 7, then I have one more path which is 5 to 8, then I have a path called 7 to 10, then I have a path called 8 to 10. Now as you can see from the network, there are 2 paths available. One is 1, 2, 5, 8, 10, or the other path is 1, 2, 5, 7, 10. So for this particular network, there are 2 critical paths available. Okay. So one path is, maybe I'll write in a different color. So there are 2 paths, 1, 2, 5, 8, 10. This is one path. The second path is 1, 2, 5, 7, 10. This is another path. So for this particular network, there are 2 critical paths available. So this is a solution by using critical path method. Thank you.